This is section 5.4, page 1 on the Pythagorean theorem. So our first theorem says the altitude drawn to the hypotenuse of a right triangle. So here we have our right triangle, okay? And then we're going to go ahead and draw the hypotenuse, or the altitude, to the hypotenuse. So this is the hypotenuse. Here's the hypotenuse across from the right angle, okay? So we're going to take and draw the altitude in. The altitude always meets in a right angle, okay? This altitude separates the triangle into two triangles, each of which is similar to each other. So they're saying these two triangles are similar to each other, and they're also similar to the original triangle. So these pictures are trying to help you understand the theorem. Okay, so the first thing they're saying is this little triangle here is similar to the original big triangle. That's not too hard to see. This is our little triangle here. This is our big triangle. Well, remember, to have two triangles similar, we just need to get two congruent angles. So we have a congruent angle here in the right angle, and then both of these are angle A. So we can see here angle A here, angle A here. So let's go ahead and put a little marking there. So we can say they're similar, okay? And we would say that it's by AA, okay? So now the next thing we want to show is that this triangle here is similar to the whole triangle. So if we take this one here, again, it has a right angle, and then they share, again, the angle B. So this triangle here, it has this B, and the big triangle has B. So this angle, okay, so they would be similar because they have right angle and this other angle. So again, by AA. So those were fairly simple. Now, the other thing we have to show is the two small triangles are similar. So when we do that, we're talking about this little triangle and this little triangle. Okay, well, clearly they both have right angles in it. So that's our first angle. Then we have to show somehow that the other angles are similar, are congruent, I'm sorry. Well, if we look at this, we might think, oh, well, see, it's congruent. Well, go back up here and look at the original triangles. We're splitting, these two triangles split this angle C into two pieces, and we don't know if it makes it congruent. And we can kind of see it doesn't look like it does. So those are not the congruent angles, okay? Rather, we have to think back of what's going on. So when we look at, notice how I've labeled these. I've labeled this little triangle comes from here. This angle is X, and this, when we look at this triangle, this is Y, okay? So I labeled those because can you see that X plus Y has to equal what? In the big triangle, so if we go to the big triangle and look, if this is 90 degrees, X and Y together have to equal 90 degrees. So we would say the measure of angle X, or we can just say X and Y. We don't have to say the measure of anything because X is standing for the measure. So X plus Y equals 90 degrees, okay? So when we're here, when we're looking here, if this is 90 degrees here and this is X, what does that have to be? Well, these two angles have to measure 90 degrees. They have to because this is 90. So if this is X from this same triangle here, then that angle has to measure Y. Likewise here, if this measures 90 degrees, then what is left for these two? 90. So if this is Y, this has to be X so that it's 90. So now look at what happens. We find that this angle here is congruent to that angle there. And this one here, we'll put 2 on that one, is congruent to this one here. All right, so these are similar also by AA. Okay, that's it for that theorem. On to the next theorem. B is the geometric mean of A and C when we can write this proportion. We write A over B equals B over C. So what I like to do is think, well, the geometric mean goes in these two places, and then the other two numbers really doesn't matter, go in here, okay? So then how do we get to this next part? We say b times b is b squared, so we're cross multiplying, equals here a times c. And then if we solve it, we would be taking the square root of both sides, remembering to put in the plus or minus. Okay, so what is the geometric mean? Well, before we answer that question, let's talk about the arithmetic mean, something you're used to, the average. So if we talk about the average of 3 and 12, how do we find an average? Think about that these are quiz scores or something. What would be right in between? That's what it means to be the average. Well, what do? We add up those numbers, 3 and 12, and then divide by the number that we have, 2. We have 2 of them. So that gives us 15 divided by 2, or 7.5, 7.5. All right, so let's look here. If we want to look at the average, 3, here's 12. Right smack dab in the middle is 7.5. So let's make a mark there. Okay, so that is 7.5. Okay, so when we move from 3 to 7.5, how many are we going? 1, 2, 3, 4 and a half. Okay, so that's 4.5 units that way. We start at 12 here and move towards 7.5. 1, 2, 3, 4.5. So let's see, let's call this 4.5 and this 4.5. Okay, so basically what we just found is that the arithmetic mean is the middle when you are adding. Okay, so it's right smack dab in the middle of these two numbers if you're adding. So if you add 4.5 and go this way, and 4.5 this way, you're right in the middle of 3 and 12. Okay, that's it for page 1. Go on to page 2.